So in a previous video, we looked at collision theory and how to increase the number of collisions happening in a set time, increasing the reaction rate. And today we're going to have a look at how energy affects the rate of reaction as well. So just to recap, for a reaction to happen, reactant particles have to collide. If there's not enough energy for the reaction to happen, this is the important part for today, then particles will just bounce off each other. And if we want a reaction to happen, we have to have enough energy, and that's called activation energy, and then the reaction will take place. So let's just do a little recap. Let's just remind ourselves what activation energy actually is. You may remember this chart. If you don't, then I'll put a link in the top corner. The activation energy we show is an upwards arrow because we need to put energy in, and it is the minimum amount of energy that we need for the reaction to happen. Okay, we need to go over the hump to get from the reactants to the products. Okay, and so that is an energy level diagram, and that's what we mean when we say activation energy. It's the minimum amount of energy that we need to get over in order to get the reaction to work. And it exists for exothermic reactions on the left and endothermic reactions on the right. So if we want to make something react faster by manipulating energy, if we give more energy to particles, then more particles will have this minimum amount of energy. Okay, if you think about it, if we have something at 20 degrees C and we have, I don't know, 20% of the particles have the activation energy, then if I raise that temperature by putting more energy in to 30 degrees C, then we find that maybe 40% of the particles will have the activation energy because I put more energy into the system. So the more energy I put in, the more particles will have the required activation energy, and therefore we will get more collisions happening which result in a reaction because they have that required activation energy. So increasing the temperature of a reaction, if you're ever asked to explain why this increases reaction rate, increasing the temperature of a reaction increases the energy of the particles. It then increases the number of particles with the activation energy, which means that we have increased the number of collisions that result in a reaction over the same period of time, and that increases the reaction rate. So raising the temperature of a reaction increases the reaction rate. That's not the only thing that we can do with activation energy, however. So you may have heard of a catalyst before, but a catalyst is something that speeds up a reaction, and the important thing about the catalyst is that it's not actually changed itself or used up. So if you put it in, let's say it's manganese oxide, and you're putting that into hydrogen peroxide, at the end of the decomposition, you would end up with the hydrogen peroxide reacting and changing into water and oxygen, and you would end up with the manganese oxide that you put in still left over at the end. It's not changed. There's no different. It does get involved, but it's actually at the end it's the same as it was at the beginning. So here are two graphs, my two energy level diagrams again, and what I'm going to show you is the effect of a catalyst on the activation energy, because a catalyst works by lowering the activation energy. Now, there's a couple of ways that it can do this. It's either because it holds particles in position, because it's acting as a surface for them to stick to, or it's because it provides like a little shortcut for the reaction to take, which doesn't require as much energy. But the important point here is that they lower the activation energy. And when we look at the graph for the exothermic reaction, that's the one on the left. If I show you that an activation energy with a catalyst looks a bit like this, you can see that the hump is lower, the activation energy is smaller, and we are therefore going to have more particles which have that amount of energy than we did particles with the higher amount of energy. So we have lowered the energy requirements, and therefore more particles will get in. Again, if I started at 20 degrees and I had 20% of the particles reacting, by lowering the activation energy, that means that without changing any temperature or anything else like that, I've suddenly made it so that maybe 60% of the particles can get over this activation energy hump. Same works with the endothermic reaction. You see I've got a smaller hump and a smaller arrow, which means that my activation energy is lower. That again means that we're going to be able to get over that energy barrier at a lower temperature than we otherwise would. So catalysts lower the activation energy, and that means that more collisions will have that reduced activation energy, and because of that, the number of collisions that result in a reaction will be greater in a given time period.